Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. Previous session, I created this model, email spam detection model, and if you look for the curriculum, then you will see these models mentioned here: KNN, decision tree, random forest. So I already created this spam email classification project earlier, but because I want to show you these algorithms, I will show you new code. If you access the previous article that is available in blog page, I have included step 9 here, training multiple models. So logistic regression, KNN, support vector machine, decision trees, random forest. So all these. So there are 5 different models now. Before telling you how this model works and what it means, and this is now the complete code with all models. Earlier, if you see, there were 2 types of code available. One is loading the saved model from the disk, and one was directly running the model from the memory. And now step 9, training multiple models. So you can find this here. I think the numbering is incorrect. I will rectify it after the session. So I will show you the output first. If I run this program, and I have copied all the code in all.py for now. So let's see the difference. Okay, so these are all the outputs. I told in earlier session how to read this output. If you forgot it, it doesn't matter, because I have mentioned in this article how to read this. So this precision, out of all emails predicted as not spam, 75% were actually not spam. So you can look for this in the article. I have mentioned everything. I will not repeat this, but tell you how these other models work in the simplest manner. So if you navigate down, so I have also included the output in this article if you want to see. So let's see the different types of models available and what they are doing. If you see, the logistic regression accuracy is 98.67%. KNN accuracy is 95.84%, and SVM accuracy 99.33%. This means each model have their own pros and cons. See, decision tree accuracy is 99.33, random forest is 99.67. So all the models have different metrics. When you run it on your computer, you will see this output, but I will tell you one by one what this model means and how it works. First I will tell you the example, then you will understand what in technical terms it is. So I have okay, so let's see. Imagine you are a doctor diagnosing whether a patient has a disease. So answer will be yes or no. Logistic regression will take patient data, for example patient age, patient weight, etc., and predict whether the patient likely has the disease. If the probability is higher than 0.5, it predicts yes, otherwise no. So what is happening is probability. In logistic regression, what is happening is probability, whether yes or no, based on the data. Which data? For example, this patient data, age, weight, etc. Now in the context of spam detection, let's see the example. Imagine you receive an email saying, congratulations, you have won this many dollars. Logistic regression will analyze the words and patterns in the email and assign a probability that it's spam, like 0.95. Since this is closer to 1, this is closer to 1, it classifies the email as spam. So this is how logistic regression works, and this is the technical definition if you want to read it. Logistic regression is used for binary classification. It estimates the probability of an event occurring by fitting the data to a logistic function. The output is always, so see, this is important, the output is always between 0 and 1, which can be interpreted as probability of the input belonging to one class. Either it will be spam or not spam. There is no third output, either spam or not spam. So these are the two examples, and this is what logistic regression is, and implementing it is easy. A few lines of code. This is how you implement logistic regression. Again, you will ask me when to use which model. I have also mentioned that in bottom of the article, so don't worry. Okay, so let's see the second one. I'm just telling you how these model works. So these are very simple models. You just have to write 2 or 3 lines of code, and that's it. You just have to understand when to use which model. All the code is already available here. So let's see KNN. Imagine you are at a park and want to predict the type of tree you are standing near. You look at the 3 closest trees around you and see that 2 are oak trees and 1 is maple tree. Since the majority are oak trees, you predict that the tree you are near is also an oak tree. So what is happening is you are looking for the nearest trees and just predicting the new tree that you are looking at. So in the context of spam email, suppose KNN checks the 5 emails closest to the one you received. If 3 out of 5 neighbors are spam, KNN will classify the email as spam. So it will see the neighbors. If they are spam, then it will classify the email as spam. So this is how KNN, K nearest neighbors, is working. So what this is, it is a simple algorithm that classify data points based on the majority class of their nearest neighbor. Remember these words, nearest neighbors, and you can see for this word also in the name neighbors. It works by comparing the new data point to the k nearest data points in the dataset and assigning it to the class with the most neighbors. New data point to the nearest data point in the dataset and assigning it to the class with the most neighbors. So what it will do is predict the new one. Predict the new one. This is what k nearest neighbor is doing, and this is the code. This is how you use from sklearn. So this is the way. I will continue this topic in next video. See you in next video. Have a nice day.